Everyone, I'm Adam Black, an aspiring R developer in the OHDSI Open Source Community, and I'm making this video about testing in the OHDSI packages. In particular, we're going to look at the ROhdsiWebApi package, go through the process of adding a test and looking at the code coverage, pushing our changes to GitHub, and doing a little bit of debugging on the GitHub Actions runners. So let's get into it. So I opened up a new terminal and I'm in my OHDSI R packages folder, and I need to clone the ROhdsiWebApi package into this folder. Okay, so now we're in the project here, and I want to make sure I'm working on the latest version. So if I run git remote-v, this shows me that I have the remotes pointing to my fork of the ROhdsiWebApi package, but I want to set up the upstream. And we're also going to switch the origin to use SSH. Now we'll pull the most recent changes from the develop branch. And we have merge conflict. So in this situation, I think what I want to do, instead of trying to fix this conflict, I want to just delete my local development branch and just restart off of the upstream development branch. Okay, so what I did was created a new branch called develop and pulled the upstream develop into that branch, and now I want to push those changes to GitHub on my fork of the package. Okay, so now I should have everything fixed. I have a local develop branch that matches the upstream OHDSI develop branch, and I've pushed that to develop branch in my GitHub account. So now we should be ready to get started. Okay, here we are in our studio. We've opened up the ROhdsiWebApi package. The description file is a very important file for R packages, and it lists the dependencies for the R package. Anything that we're using for tests needs to go in either imports or suggests. If you're only need it for tests, you can just put it in the suggests field. So we're using the test that package to do testing. We have a folder in each of the R packages called tests, and this is where all of the unit test code belongs. Of particular note in the description file is this HTTP test package. So this is the package that we're going to use to be able to test the web API endpoint without needing access to a live endpoint. And this is done by caching the results from calls to the API endpoint. If you're going to work on this package, it's probably a good idea to read over this web page that describes the HTTP test package and how it's used. So here's a README file that describes how we are using a mock web API endpoint to do our testing. We do have a web API endpoint that we can use, a publicly available web API endpoint we can use to test this package, but what this does is kind of caches those results, so it allows us to run tests against those cache results rather than always hitting the web API endpoint. This also means that we can run tests from the GitHub Actions servers without needing to mess with networking or access to the actual web API endpoint. So every file in the R folder, this is where the R code for the package lives in the R folder. Each one of these files has a corresponding test file in the test.that folder. For example, functions that deal with analysis generation are in the r/generation file. And the tests for those functions go in the test.that testgeneration.r file. And the cached web API data needed to run those tests is stored in test.that mocks generation. So we can see that we have in the generation file the invoke generation function, get generation information, cancel generation. If we go to tests, test that, test generation, we're testing invoke generation, get cohort generation information, all these generation functions. We can run a single test just by loading the package, and we also need to load test that. So when I try to run this, it says that the base URL is not found. So that's because it is set in the setup folder. So I'm just going to run all the code in the setup folder. Now I have the base URL. This is coming from an environment variable. And let's try to run this test here. So this passed, and this ran very quickly because it didn't actually query this endpoint. What it did was looked at the stored data. So if we look in here, we've got a generation folder. And so this is structured like a URL, atlas dev odyssey.org, web API, and we can see that this is an object. So it's a list with a class attribute that represents the response from the web API endpoint. So suppose we've made a change to our tests and we want to actually refresh this cache. All we have to do is delete this folder. Okay, so it's gone. And we'll rerun that test. Now it's going to take a little bit longer because it has to actually go out to this atlas-dev odyssey.org/webapi endpoint and run the test on that endpoint. And we see our tests passed. And now we have the folder was recreated, generation. And so this data was saved back into the cache. If you want to restore the entire cache, you can just delete the entire mocks folder and rerun all tests. So essentially what this will do is if if the cache exists, it will use the cache. If it doesn't, it will go out and to the endpoint and use that for tests. To run all tests, we can just say on the build tab, there's a test package button. You can also just do a keyboard shortcut. And it's good to run these tests frequently and check for errors. So here we see that all of our tests passed, and they ran very quickly because we're using cache data. The next thing that I want to talk about is how to understand the code coverage of the package and figure out where you might want to add new tests. So to do this, we'll use this function called report in the covar package. I'm not sure why this viewer is so collapsed. So we'll try running it again, and we'll create a static HTML file inside our project directory. I'm not sure why this viewer is so tiny. We have one row for each file, and we can see on the right-hand column the code coverage for that file. 90% is really good. 20% is not good. We can click on one of these files, and we can see the actual lines that are not covered by tests. Coverage just means, does this line get executed at all when the tests are executed? So code that's not covered by tests means that it's not executed during testing, and there's really very little guarantees that it will work. And so just executing the code alone is a good idea, because it ensures that the function actually continues to work. So notice that comments are excluded. They're not part of the coverage, but we can see that a lot of these functions are not being tested. So how do we improve the code coverage? Well, we need to write a test that calls this function and runs this code. So get concept set definitions metadata. This is a simple function that just is a get request, and so this should be pretty easy just to add this test. So we'll look here. It's in the auto-generated definitions file. ROhdsiWebApi has functions that are written through a metaprogramming type of approach. This has some pluses and minuses. So the plus is that you can create a large number of functions very easily, but the minus is that to modify these functions, you have to work on the code that writes the code rather than the actual code itself. So at the top of this file, it says this file has been auto-generated, do not change by hand. So if you want to make any modifications to this file, what you have to do is go into the ROhdsiWebApi extras folder and modify this code here, which is the code that writes the R code. So this function that we want to cover with tests is part of these auto-generated definitions created using a meta-programming approach. And what's actually happening here is what's called partial application. And so we have this more general function, get definitions metadata. It has 2 arguments, and we are creating a new function that sets one of those arguments to a static value. So this is essentially partial application. There is a related idea called currying, where we can take a function of multiple arguments and rewrite it as the composition of a function of multiple functions, each of a single argument. This is essentially partial application. The way it's done is using kind of a macro-based approach where we're kind of doing find and replace in text and then writing that text to the file. The per package has a function called partial, and what this does is takes in a function of multiple arguments and allows you to set one of those arguments to a static value, and it returns a new function. So one idea might be to make use of this idea of partial application. That might simplify the maintenance of this package, because it is kind of difficult to modify this code. And if we wanted to make a change to say this function here, or even the documentation, we would have to regenerate this whole file, and so the commit would be large potentially, because all of these potentially a lot more would change than we really want to. So if we just want to be able to change one function, we're kind of forced to regenerate this whole file. Okay, back to the test. So where should we put this test first of all? Let's just see if we can run it. We have base URL. Okay, and we'll say get concept set definition, metadata, pass in the base URL, and it works. So that's good. We need to now just create a test where we're calling that function and put it in the right place. So here we have test auto-generated-definitions.r. Okay, so it looks like this was started, but for whatever reason was commented out. And the approach that was being used here was maybe writing some sort of loop that would loop over testing a whole bunch of these functions at once. So probably there is some efficiency we might be able to get by creating kind of a series of tests that goes through these auto-generated definition and tests all of them. For now, for this demonstration purposes, I'm just going to create a new test for this one function, and this is how you would normally do it if you're kind of testing for a single function. If you have some broader pattern, then you can maybe do some sort of looping to make the code base, to make the test code a little more concise. But most of the time, you'll just be writing one single test or multiple tests for a function. What we need to do here is, we'll say test that. And we have to have a short description of what we want to test. So I'm just going to say we want to test that get concept set definitions metadata works. Then we pass in our expression. So remember that we do have base URL. That should be loaded. So all we really have to do is just call this function with base URL. We don't necessarily need to name the argument because it's the only argument to this function. If we're being a little more strict in our development, maybe assigning based on name is probably a good idea. And so this is the code that will run. And this is our data frame. This is what it returns. So we need to write some sort of check to make sure that this this worked. So there are a whole bunch of expectation functions in the test that package, and we can use these to check the result of our function call to make sure that it worked. Expect LTs, expect less than equal. I'm going to say expect S3 class. So I'm going to check that this is a data frame. And I'm going to expect that the number of rows is greater than 1, greater than or equal to 1. I could also check the names of the data frame. But then if the names ever changed, that would break this function. So it's kind of, this is where we can actually test the API of the function. So this function is supposed to return a data frame with a special format, and we have to think about what kind of guarantees that function has. Like, is it saying that that the columns of the data frame are going to be named certain things? If yes, then we kind of want to include that in the test so that if other people are relying on that in their code, we want to just be aware of it if we break that API. So if changing the name of the column might break someone else's code, then we want to include that in the test so we can keep track of it. So I think that we actually want to test that the column names are in the right order and have the right values. So we're checking that it's a data frame, it's got at least one row, and that the column names match. We could also check the types of the columns. Okay, so here we're checking that the first two columns are date fields, and the next one is logical, the next one's integer, next one's character. Another thing that we might want to check in a test is how the function handles bad data. So we can do that by testing its error messages. So we can say expect error, and here we can call the function with a bad argument or with no data. So let's see, get concept set metadata, and if we call it without anything, it should just give us a missing base URL is missing. So as the second argument, we put in a regular expression that should match the error message. So I'm just going to say is missing. So this check passes because it does throw an error that does match is missing. And what happens if we just give it something that's not an actual URL? We get a message about could not resolve host. Okay, so we'll put that in our regular expression string, and now we have tested that this function kind of correctly throws an error when we expect that it should give an error. And I think that's all we need to do for this function. We have tested that it returns a data frame, that the data frame has at least one row. In general, this function could return a data frame with 0 rows, I think. And it might be good to check what happens in that case. Do these tests all pass? If the WebAPI endpoint has no concept sets in it, do we still get a data frame back that has the right types, has the right names, etc.? So that's the type of thing that we're doing here, is we are testing the function interface. We're saying, what are we guaranteeing to the user of this function that they're going to get back when they call it? And this test is the way that we guarantee that the function returns what it's supposed to return. If we ever make a change to the function that breaks that interface, maybe changes the column names or the types or something like that, then this test will fail, and it will just let us know that we need to change the test, or that we're in some way breaking the interface. And now we can see that that this function is now covered in green. So we have increased code coverage by a tiny amount and covered 3 new lines of code. So for this file, it might be possible to do some sort of kind of batch testing, but this is basically the idea for adding the tests. So this will push the changes to my fork. If I go to my GitHub page, I can see that I have this notice here that says I had to push 1 minute ago, and I can create my pull request here that will let the maintainer of this package know that I've added a test and I'd like to get the code integrated into the code base. If there's a particular issue or something, I can reference that here. But that is the process of creating tests, particular for the ROhdsiWebApi package. When we make changes to the package, we want to make sure that these changes don't break things. And if you run tests on your local computer, that's great because you're checking that it works there. But we also want to make sure that it works across many different environments, and in particular on the servers that CRAN will use. So we have GitHub Actions set up as a way that we can, for free, run all these tests as well as our command check on a variety of platforms. So here we're running it on the current release version of R on 3 different operating systems: Windows, Mac, and Ubuntu. And every time I push to my my GitHub remote, it will trigger these tests, as well as when I create a pull request. It will also trigger these tests. Sometimes you need to have environment variables set in order for these tests to run correctly. In our case, we needed the base URL to be set. So we have to make sure that that environment variable is set in the settings of this package. And this is going to be done under the secrets section of under settings. So you have to create these environment variables here, and and then these environment variables will be accessible on the machines that are running the tests. Yet before any OHDSI package gets released, we have to make sure that the tests run successfully on all of these platforms. We can easily run our command check locally by just clicking this check button here, and this will run kind of all the standard checks that get executed on a package. So it's good to do this also when we're running tests, but our command check is separate from the unit tests that we've been working on, although unit tests are executed as part of our command check. So here we can see that something failed that one of our tests failed, and it has to do with the column names of the data frame. So the question then is, why is the test passing here but failing on the GitHub runner? So in general, debugging GitHub debugging your code on these runners is quite difficult, or time consuming, I should say, because what you have to do is make a change to your code, rerun the actions. This takes about 7 minutes or so, or 5 minutes, somewhere around there, and then you might get some sort of feedback, and then you can make another change and see what that is. So what I did was I just created another commit and tried to print out the column names, because I want to know what does, when this code is running here, what is the output of call names df on this machine. So I just added a print statement and reran everything on the GitHub Actions runners. I could just be doing this on one, since I don't really need to run it on all three, since the issue has more to do with something else. It's not the operating system. I still get an error as I expected, but I do get this print message, which is helpful. So I'm printing out the column names of that data frame. And when I ran it locally, I got 5 column names: created date, modified date, has write access, ID, and name. When I run it on GitHub Actions, I'm getting this additional column called tags, which makes me think that the Web API endpoint that is being used here is actually different than the one I'm using. And so it's, it must be pointing to a different Web API endpoint, and so it's getting different data. So what this tells me is that the column names this is not something necessarily stable across all Web API endpoints, meaning that depending on which base URL you're using and what version of Web API you're using, you may get different column names. So in the R code, we don't necessarily want to guarantee that that the column names are going to be the same. This might make it. I'm not sure exactly what the guarantee should be. So if we look at the help documentation for this function, it tells us that what's returned is a tibble of the specification metadata for a concept set. And so it's not necessarily saying exactly what those columns should be. It's just going to give us some information about that. So for now, I think I will just remove this test. Okay, what I'm doing instead is just saying that the data frame must have these column names, but it could also have additional column names, like, for example, the tags column name. And that still works. So I'm going to make the commit and rerun it on GitHub Actions. I want to show you an approach to, if you're working on debugging stuff in GitHub Actions, all of that is controlled in this file, this YAML file, under .github workflows here. So there's documentation on GitHub's website about the structure of this file and how it works. We're just going to run the actions, the tests and stuff on all pushes to all branches, on all pull requests to all branches. And then we're running on 3 different platforms. So what I'll do is maybe only use Windows for now. I can just comment those out and have to commit those changes. So I might have a lot, when I'm working on debugging GitHub Actions, I might have a lot of commits that are basically debug GitHub Actions. That's okay, because they can all get squashed into one larger commit when we do a merge. So, a bunch of small commits about debugging is fine, and then we'll just collapse them all down to one commit when we merge. Okay, so I pushed it back to GitHub, and Now we go back to actions. And we see now we're only running on Windows, so we don't need to waste computation time. Even though these do run in parallel, there's no reason to run all three of them when we're just trying to get the test to work. Once we get it working on one, then we can run it on all three, and we definitely need to make sure that it passes on all three before we release anything. Okay, so we got to fail pretty quickly. I think that this probably doesn't have anything to do with our code. This is something, maybe this is something about this external, some external resource not being available. So let's go back and just try it on Mac instead. A lot of what we saw here was just the that we had some assumption about, or I had some assumption about what the structure of the data frame was going to be from that one function call, getting the metadata. And that assumption wasn't correct, in that depending on which version of WebAPI you're using, you might get different columns in that metadata column. So in general, it's just an example of checking your assumptions and coding those assumptions into tests, and the assumptions that you kind of want to be guaranteeing to your users should be coded in tests, and just getting a handle on what kind of assumptions are we guaranteeing to the users of this function, so that they know what the in this case what the column names are of the data frame. Okay, we can see that everything worked. Our tests worked, which is great. Okay, well, thanks for sticking with me through that long video about testing, and we had a bit of a detour at the end for debugging on GitHub Actions, but that's definitely part of the reality of trying to get tests working and get our integration working. So I think it was good to show that. If you have questions or comments, feel free to leave them here or on YouTube or in the open source community work group. I'd love to hear them, and any requests for other videos you'd like to see about the OHDSI R packages. And with that, I'll see you in the next video. Thank you.